For decades, scientists assumed it was simply impossible. Egyptian mummies, preserved through a process specifically designed to stop decay, sitting for thousands of years in one of the hottest climates on Earth, were considered a genetic dead end, bodies chemically treated in ways researchers believed would destroy any usable DNA long before modern technology could ever read it. Then a team of geneticists finally cracked the problem, extracting real usable genetic material from 90 mummies spanning over 1,300 years of Egyptian history. And when they compared that ancient DNA to the DNA of Egyptians living today, the result was not what anyone expected. Modern Egyptians turned out to be genetically different from their ancient predecessors in a direction almost nobody had predicted. Stop and think about that for a second, because it immediately raises a question most people have never considered. If you assume ancient and modern Egyptians are basically the same population, just separated by time, then any difference between them should feel surprising. But the direction of that difference, once researchers finally saw it, contradicted assumptions held by different groups of people for entirely different reasons, turning a purely scientific finding into something that would spill directly into one of history's longest-running cultural arguments, one that had been simmering in universities, museums, and online debates for far longer than most people realize. To understand exactly why this finding stunned researchers, and why it immediately became entangled in one of the most heated and long-running debates in all of ancient history, you first need to understand just how difficult this research actually was to conduct in the first place, and why the ancient Egyptians themselves, without ever intending to, created one of the hardest genetic puzzles scientists have ever tried to solve. Ancient Egyptian mummification was never designed with future genetic research in mind. It was a religious and cultural practice meant to preserve the body for the afterlife, involving the removal of internal organs, the use of natron salt to dry out tissue, and the application of various resins and oils meant to protect the body from decay for eternity. From a purely biological standpoint, this process is almost perfectly engineered to destroy DNA. The chemicals used in embalming break down genetic material. The dehydration process damages the delicate molecular structure DNA depends on to remain readable. And Egypt's climate, hot and dry for most of the year, but subject to periods of humidity that can be devastating for preserved biological tissue, creates exactly the kind of environment where ancient DNA tends to degrade fastest and disappear soonest, compared to the cold, stable conditions found in places like Siberia or Northern Europe, where some of the best preserved ancient DNA samples in the world have been recovered. Researchers studying ancient DNA preservation have identified specific chemical culprits within the mummification process itself that make the situation even worse than climate alone would suggest. The resins and oils used by ancient Egyptian embalmers, while remarkably effective at preserving soft tissue and skin for thousands of years, contain compounds that actively bind to and damage DNA molecules at the chemical level, effectively working against the very technology future scientists would eventually try to use on these remains. In a strange sense, the ancient Egyptians were so extraordinarily good at preserving bodies for the afterlife that they accidentally became far better at destroying the genetic information those same bodies carried, a genuine irony that made this eventual breakthrough considerably more difficult and more impressive than similar discoveries made using unembalmed skeletal remains elsewhere in the world. It is the scientific equivalent of a locked room mystery, where the very act of sealing something away for preservation is precisely what makes it so difficult to eventually open and read. This is precisely why, for years, Egyptology and population genetics rarely intersected in any meaningful way. Earlier attempts to extract DNA from Egyptian mummies, dating back to the 1980s, produced results that later turned out to be contaminated, unreliable, or simply impossible to verify using the technology available at the time. The scientific consensus that gradually emerged was cautious and somewhat pessimistic. Egyptian mummies, despite their incredible state of physical preservation, were likely genetic dead ends, too degraded and too contaminated to ever yield the kind of clean, reliable ancient DNA that had already transformed the study of populations in Europe and Asia. The team that eventually solved this problem approached the challenge differently than earlier researchers had. Rather than attempting to extract DNA from bone, the material most commonly used in ancient DNA research elsewhere in the world, researchers focused specifically on teeth, which offer significantly better genetic preservation because the dense enamel surrounding the tooth's inner pulp cavity provides a natural barrier against many of the environmental factors that destroy DNA elsewhere in the body. Working with mummified remains recovered from a site called Abu Sir el-Malek, located along the Nile in Middle Egypt, researchers applied newly developed sequencing techniques specifically designed to work with the kind of highly fragmented, damaged DNA typical of ancient and poorly preserved samples, techniques that had only become available in the years immediately before this research began. Abusir el-Melek itself was a well-chosen site for this attempt, an ancient settlement with a long history of continuous burial activity spanning many centuries, giving researchers access to a genuinely deep archive of mummified remains from a single location, rather than having to piece together samples scattered across dozens of unrelated sites. The specific technique that finally made this breakthrough possible is worth understanding, because it represents a genuinely clever solution to an extraordinarily difficult problem. Rather than attempting to sequence an entire genome from scratch, which requires relatively intact, high-quality DNA that simply was not available in these degraded samples, researchers used a method called targeted enrichment, essentially fishing for specific, predetermined stretches of genetic code known to be informative about ancestry and population history, rather than trying to read every single letter of DNA present in the sample. This approach allowed scientists to successfully extract meaningful genetic information even from badly fragmented and chemically damaged DNA, working around the limitations of the sample, rather than requiring pristine genetic material that Egyptian mummies, given everything discussed so far, were never going to provide. The results, when they finally came in, exceeded almost everyone's expectations. Researchers successfully recovered usable genetic material from 90 individual mummies, spanning an extraordinary period of Egyptian history, from roughly 1400 BCE during the New Kingdom period, through the Ptolemaic period following Alexander the Great's conquest, and continuing into the Roman period, a combined time span of well over 1,300 years. This gave scientists something almost unheard of anywhere else in the ancient DNA field, a genuinely continuous genetic record from a single population, sampled repeatedly across more than a millennium, allowing researchers to actually track how, or whether, the genetic makeup of this population changed over an enormous span of recorded history. And this is where the first genuinely surprising finding emerged. Despite Egypt experiencing wave after wave of foreign conquest and political upheaval throughout this 1,300-year window, Persian invasion, the arrival of Alexander the Great, and the establishment of Greek Ptolemaic rule, and eventually incorporation into the Roman Empire, the genetic profile of the population sampled at Abusir el-Melek remained remarkably stable and consistent across the entire period studied. Ancient Egyptians living during the New Kingdom showed a genetic profile strikingly similar to ancient Egyptians living well over 1,000 years later, under Roman administration, a level of genetic continuity that surprised researchers who had expected to see clearer evidence of disruption or replacement corresponding to these major political transitions. This stability becomes even more remarkable when you consider what was actually happening on the surface of Egyptian society during this same period. The Ptolemaic dynasty, founded by one of Alexander the Great's own generals, ruled Egypt for nearly 3 centuries as a Greek-speaking royal family presiding over an Egyptian population, culminating famously in the reign of Cleopatra, the last Ptolemaic ruler. Greek became an important administrative and elite language throughout this period. Greek cultural influence reshaped Egyptian art and architecture in some regions, and yet, according to the genetic evidence recovered from this study, none of this elite-level cultural transformation appears to have been accompanied by anything resembling large-scale genetic replacement of the broader Egyptian population living and dying along the Nile during these same centuries. The second finding, and the one that would eventually generate the most attention and controversy, concerned exactly which modern and ancient populations these ancient Egyptian samples most closely resemble genetically. When researchers compared the ancient Egyptian DNA to reference populations from around the world, the ancient Egyptians sampled in this study showed their closest genetic affinities, not with populations from Sub-Saharan Africa, but with populations from the Near East, including the Levant, the region covering modern Israel, Palestine, Lebanon, Jordan, and Syria, as well as populations from Anatolia and parts of the Eastern Mediterranean, a genetic signature consistent across the entire 1,300-year period the study examined. This finding immediately stepped into the middle of a debate that has simmered within Egyptology, anthropology, and popular culture for well over a century, the question of the racial identity of the ancient Egyptians. For decades, this question has been argued from multiple directions, with some scholars and popular writers, particularly within certain strands of Afrocentric historical scholarship, arguing that ancient Egyptian civilization was fundamentally a black African civilization whose true racial identity has been historically obscured or minimized by Eurocentric scholarship, while other researchers have argued for a closer connection to Mediterranean and Near Eastern populations, a debate that has often generated more heat than careful scientific analysis, partly because, until this study, there had simply never been reliable ancient DNA evidence available to actually test either claim directly. This debate has real cultural weight behind it, extending well beyond academic circles into museums, documentaries, casting decisions in film and television, and even school curricula in different parts of the world, precisely because the identity of one of history's most celebrated civilizations carries enormous symbolic significance for how different communities today understand their own connection to that legacy. For generations, This argument played out almost entirely through indirect evidence, artistic depictions open to varying interpretation, and outdated anthropological methods, with genuine biological data conspicuously, and for a long time seemingly permanently, absent from the conversation. It is critically important to understand exactly what this study did and did not establish, because oversimplifying its findings in either direction badly misrepresents the actual science. The genetic samples this research successfully analyzed came from a single archaeological site in Middle Egypt, representing a specific, relatively narrow window of Egyptian geography and history, roughly the New Kingdom through the Roman period. This tells researchers a great deal about the genetic ancestry of this specific population at this specific site during this specific historical window. But it cannot, on its own, definitively settle questions about the genetic makeup of ancient Egyptian populations more broadly across the full 4,000-year span of Egyptian civilization, or across the full geographic range of ancient Egypt, from the Nile Delta in the north to Upper Egypt and Nubia far to the south, regions that almost certainly carried somewhat different genetic profiles reflecting their different geographic positions and different patterns of contact with neighboring populations. Researchers involved in this study were careful to note this limitation clearly in their published findings, emphasizing that their samples, drawn entirely from Middle Egypt, cannot be assumed to represent the genetic profile of ancient Egyptians living in Upper Egypt, much closer to Nubia and Sub-Saharan Africa, where genetic and cultural connections to populations further south along the Nile were almost certainly stronger throughout ancient Egyptian history. Ancient Nubia, the civilization immediately to the south of Egypt along the Nile, had deep, well-documented cultural, political, and likely genetic connections to populations further south. And at various points in history, including during the 25th dynasty, Nubian kings actually ruled over Egypt itself, a historical reality that this specific study's narrow geographic sampling simply could not directly address. This is precisely why the researchers behind the study, and most serious geneticists who have discussed these findings since publication, consistently urge caution against treating this single study as the final word on ancient Egyptian ancestry as a whole. Science generally advances through exactly this kind of incremental, geographically limited evidence, one site, one time period, one specific population sample at a time, gradually building toward a fuller picture rather than delivering complete, definitive answers in a single publication. Anyone citing this study to make sweeping claims about the entire genetic history of ancient Egypt in either direction is stretching the actual evidence considerably further than the researchers who generated it ever intended. With that essential context established, the study's most genuinely surprising and, for many people, unexpected finding still remains: the comparison between this ancient genetic sample and the DNA of modern Egyptians living today. Given the geographic continuity, the same land, the same river, the same general region, many people might reasonably assume that the genetic profile of modern Egyptians would look essentially identical to their ancient predecessors, or perhaps show a gradual increase in genetic connection to the broader Arab world following the 7th century Islamic conquest of Egypt. What the researchers actually found was different, and in a way that surprised even the scientists conducting the study. Modern Egyptians, when compared against this same set of ancient DNA samples, showed a measurably higher proportion of Sub-Saharan African ancestry than the ancient Egyptian samples did, a genetic shift the researchers estimated at roughly 8% higher on average. In other words, rather than the ancient population carrying more Sub-Saharan African ancestry that somehow diminished over time, the actual genetic trend ran in the opposite direction entirely. Sub-Saharan African genetic ancestry within the Egyptian population appears to have increased over the roughly 2,000 years, separating the most recent ancient samples in this study from the modern Egyptian population sampled for comparison. This finding directly challenges assumptions running in multiple directions at once, which is part of why it generated such significant discussion when it was first published. It complicates the Afrocentric argument that ancient Egyptian civilization was predominantly Sub-Saharan African in genetic origin, since the ancient samples analyzed showed closer genetic ties to the Near East than to populations further south. But it equally complicates any assumption that modern Egyptian identity, particularly modern Egyptian Arab identity, represents some kind of unchanged continuation of an ancient genetic profile untouched by later historical change, since the actual data shows the opposite pattern. A population that has become measurably more connected to Sub-Saharan Africa genetically over the past 2,000 years, not less. Researchers proposed several historical explanations for this increase, factors that align well with what is already known about Egypt's more recent history. The centuries following the period covered by this study's ancient samples saw dramatically increased trade, mobility, and population movement along trans-Saharan and Nile Valley trade routes, connecting Egypt more extensively with populations further south than had been the case during the earlier periods sampled in the study. The Arab conquest of Egypt in the 7th century, and the centuries of Islamic rule that followed brought Egypt into a vastly expanded trade and political network stretching across North Africa and connecting, both directly and indirectly, with trans-Saharan trade routes that carried goods and people between Sub-Saharan Africa and the Mediterranean world. The historical trans-Saharan slave trade, a documented and significant feature of North African history for well over 1,000 years, similarly contributed to increased population movement and genetic exchange between Egypt and populations further south along these same trade networks, a pattern of increasing connectivity rather than decreasing connectivity across this later historical period. There is a particularly telling detail buried within this explanation, one that quietly undercuts a common but historically inaccurate assumption people sometimes make about this period: the idea that the Arab conquest of Egypt somehow introduced a completely new population that displaced an existing one. The genetic evidence instead points towards something more gradual and more geographically specific: increased connections specifically toward populations further south along established Nile and trans-Saharan trade networks, a pattern connected primarily to economic and trade relationships rather than to a single conquest event, and one that continued developing over many centuries rather than arriving all at once in the 7th century. Improvements in transportation and increased connectivity along the Nile River itself over the following centuries likely played a role as well, gradually increasing the movement of people and therefore genetic exchange between different regions of the Nile Valley that may have been somewhat more genetically isolated from one another during the earlier historical periods this study's ancient samples represent. Taken together, these historical factors paint a picture consistent with what the genetic data actually shows: a population becoming progressively more genetically connected to populations further south over the roughly 2,000 years following the period this study's oldest samples were drawn from, the exact opposite of what many casual assumptions about ancient versus modern Egyptian identity might predict. This finding also offers a valuable, if somewhat uncomfortable, lesson about how easily assumptions about ancient populations can be shaped more by modern political and cultural debates than by actual genetic evidence. For over a century, arguments about the racial identity of ancient Egyptians have often been conducted with remarkably little direct genetic evidence to draw from, relying instead on interpretations of ancient artwork, skull measurements using now widely discredited 19th and early 20th century methods, and broader assumptions rooted in the racial theories and political contexts of the era in which earlier generations of scholars were writing. The arrival of genuine ancient DNA evidence, however limited in geographic scope, offers something these earlier debates never had: actual biological data from actual ancient individuals, data that complicates, rather than neatly confirms, several of the more simplified narratives that had previously dominated popular discussion of this topic. It is worth naming those now discredited skull measurement methods a little more directly because they played a genuinely significant and genuinely troubling role in shaping earlier scholarly assumptions about ancient Egyptian identity. Craniometry, the practice of measuring skull shape and size to draw conclusions about race and even intelligence, was widely used by 19th and early 20th century researchers studying Egyptian remains, and it was, without exaggeration, deeply entangled with the racial pseudoscience of that era, producing conclusions that frequently reflected the assumptions and prejudices of the researchers conducting the measurements, as much as anything resembling objective biological reality. Modern population genetics does not simply improve on these older methods. It replaces a scientifically bankrupt approach with something built on an entirely different and far more rigorous foundation of evidence. It is worth emphasizing again just how technically difficult obtaining this evidence actually was, because the scientific achievement here extends well beyond the specific historical findings themselves. Successfully recovering genuine ancient DNA from 90 separate Egyptian mummies, spanning over 1,000 years of history from a region long assumed to be almost hopelessly unsuitable for this kind of research, represents a genuine breakthrough in ancient DNA methodology, one that has since encouraged other research teams to revisit mummified and otherwise poorly preserved remains from similarly challenging climates across the Middle East and North Africa, regions that had previously been largely written off as unsuitable for this kind of genetic research entirely. What started as a single painstaking success story with 90 Egyptian mummies has, in the years since, become a genuine methodological template for an entire subfield of ancient DNA research still very much in its early stages. This breakthrough carries significant implications extending well beyond Egypt itself. If researchers can successfully extract reliable ancient DNA from mummified remains in one of the hottest, most genetically hostile climates on Earth, similar techniques may eventually unlock ancient genetic data from other historically significant but climatically challenging regions, where researchers had previously assumed direct genetic study was simply impossible, potentially opening up entirely new chapters of ancient population history across the Middle East and North Africa that have, until now, remained accessible only through fossils, artifacts, and written historical records, without any direct genetic evidence to confirm or complicate the picture these other sources provide. Researchers have already begun applying lessons learned from this Egyptian breakthrough to mummified remains recovered from other hot, historically challenging regions, including sites across the broader Middle East and parts of North Africa, where similar preservation conditions had long discouraged serious attempts at ancient DNA extraction. Each successful new recovery adds another data point to a rapidly growing understanding of exactly which environmental and chemical factors matter most for DNA preservation, knowledge that continues feeding back into improved laboratory techniques capable of squeezing usable genetic information out of samples that only a decade earlier researchers would have dismissed without a second attempt. The genetic continuity researchers found across the roughly 1,300 years covered by their ancient samples also offers a fascinating window into just how culturally and politically resilient ancient Egyptian civilization actually was, even as it experienced repeated foreign conquest and political upheaval. Persian conquest, Greek Ptolemaic rule, and eventual incorporation into the Roman Empire each represented genuine, historically significant disruptions to Egyptian political sovereignty. Yet none of these transitions appear to have produced a dramatic, detectable shift in the underlying genetic profile of the population sampled in this study, suggesting that these were, in genetic terms, changes of ruling administration rather than large-scale population replacement, a pattern researchers have now documented in numerous other regions shaped by conquest throughout history, where political and cultural transformation frequently outpaces genetic change by a considerable margin. A lesson this channel has now traced across Turkey, Arabia, and Egypt alike, three very different empires arriving at the exact same underlying genetic truth. This pattern connects Egypt's genetic history to a broader theme running through population genetics research conducted across many different regions of the ancient world. The recurring finding that conquest and political upheaval, however historically significant, rarely produce the kind of dramatic genetic replacement that popular historical narratives often assume. Just as researchers have found in Turkey, across the Arab world, and in numerous other regions shaped by successive waves of foreign rule, the underlying genetic ancestry of a settled agricultural population, particularly one as large, established, and continuously inhabited as ancient Egypt, tends to prove remarkably resilient to political change, even when that population's language, religion, or ruling administration shifts dramatically within a relatively short span of historical time. What makes this entire story so scientifically valuable, beyond its specific findings about Egyptian population history, is what it reveals about the limits and possibilities of ancient DNA research more broadly. A region long assumed to be genetically unreachable, its mummified populations considered a fascinating archaeological resource, but a genetic dead end, turned out to hold recoverable genetic information after all, information that directly challenged assumptions held by scholars and the public alike in multiple different and sometimes contradictory directions simultaneously. The ancient Egyptians sampled in this specific study were not, based on this evidence, predominantly Sub-Saharan African in genetic origin, contrary to some popular historical claims. But modern Egyptians are also not simply an unchanged genetic continuation of this specific ancient population, contrary to a different set of popular assumptions running in the opposite direction. None of this diminishes the extraordinary historical and cultural significance of ancient Egyptian civilization, one of the most influential and enduring civilizations in all of human history, whose art, architecture, writing, and religious traditions continue to fascinate and influence the world thousands of years after the last pharaoh ruled. If anything, this genetic research adds a layer of nuance and complexity entirely appropriate to a civilization that spanned thousands of years, incorporated influence from Nubia, the broader Near East, and eventually Greece and Rome, and left behind one of the richest and most thoroughly documented historical records of any ancient society on Earth. A population whose genetic story, like its historical and cultural story, turns out to be considerably more layered and more geographically connected than any single simple narrative could ever fully capture. Consider, too, just how many different peoples and cultures ancient Egypt actively engaged with over the full sweep of its recorded history, long before any of the foreign conquests discussed throughout this video ever began. Egyptian records describe trade expeditions to the land of Punt, likely located somewhere along the Horn of Africa, diplomatic marriages with Near Eastern royal families documented in the famous Amarna letters, military campaigns and captives brought back from Nubia and the Levant alike, and a royal court that, across different dynasties, included individuals of demonstrably varied regional origin. A civilization this extensively connected to the wider ancient world for well over 3,000 years was never likely to fit neatly into a single, uncomplicated genetic category. And the DNA evidence recovered so far only reinforces exactly how naive that expectation always was. So when you look at ancient Egyptian mummies today, preserved so carefully for a journey into the afterlife, their embalmers could never have imagined would eventually include a modern genetics laboratory. Remember, that the DNA researchers finally managed to extract from them told a story more complicated and, in some ways, more surprising than either side of a century-old debate had ever quite gotten right. A population most closely connected genetically to the Near East. During the 13 centuries, this specific study examined, and a modern population that, rather than staying frozen in time, has continued changing, mixing, and connecting with populations further south along the Nile for the roughly 2,000 years since. Two very different mistakes were possible here, and this study managed to correct both of them at once. The mistake of assuming ancient Egypt was simply a black African civilization whose identity had been erased by later scholarship, and the equally mistaken assumption that modern Egyptian identity represents an unbroken, unchanged genetic continuation of the pharaohs. Neither survives contact with the actual data. What survives is something messier, more historically grounded, and ultimately more respectful of just how long and how eventful Egypt's true history along the Nile has actually been. If this kind of hidden history fascinates you, this is only the beginning of what ancient DNA can reveal about civilizations we think we already understand completely. Nearly every ancient population on Earth carries a genetic story more complicated than the simplified version taught in textbooks, but few have been debated as fiercely, or for as long, as the population behind one of history's most famous civilizations. Make sure you are subscribed, because in the next video, we are going to dig into the ancient DNA of another population whose modern identity may be hiding an equally surprising and equally ancient genetic secret. If you found this breakdown valuable, leave a comment and let us know which population's DNA story you want uncovered next. For over a century, people argued about who the ancient Egyptians really were without a single strand of their actual DNA to settle the question. Now that the DNA is finally spoken, it turns out the truth was more interesting and more complicated than anyone arguing on either side had ever expected, and that, more than any single number or percentage, maybe the most important finding of all,